Welcome back, class. Now that we've had a chance to look at some quadratic equations and to graph some parabolas, it's time we start looking for how to use that information to help us solve some problems. So one piece of information that's really important to mathematicians and scientists as they're looking to solve problems is quadratic roots. And the quadratic root is where that parabola crosses the x-axis. Okay, so depending on where that parabola is, you could have a couple different situations and a couple different solutions. So quadratic roots are also called sometimes zeros, or sometimes you'll hear them just called the solutions, or sometimes you'll hear them be called the x-intercept. And all of those are right terms, all of those work. Alright, so one situation is you could have a quadratic curve or a parabola that crosses the x-axis twice. And we see parabolas like that all the time. It crosses the x-axis right here and right here. So that type of parabola would have two solutions or two quadratic roots because it crosses the x-axis twice. Another situation is you could have a parabola that only crosses the x-axis once. You could have something like that where the parabola goes up to the x-axis, hits it at one particular point, and then falls back off. Okay, and in that case, you would only have one quadratic root or one solution. And then finally, you could have a situation where the parabola does not cross the x-axis at all. It's just out there in space. It could look something like this. Okay, and of course, in this third solution, that parabola never crossed the x-axis, and it's never going to cross the x-axis. It's just out there. In this case, you would have no solutions or no quadratic roots. All right, so now let's take a look at some examples. You have these same examples in your notes, so just follow along with me in your notes, and we'll go over how we can use this information to find out the number of solutions. Alright, so the first example in your notes is the quadratic equation. It's y equals x squared plus 4x minus 5. And I went ahead and put a bunch of this information already on the on my board here because this is what we've been working on for the last few days now. And I think that you guys got a hang of it and you guys can do this on your own. But of course, the first thing that we always do, I'm looking to graph this quadratic equation. So the first thing that I always do is I find my axis of symmetry. Okay, and I use my equation, negative b all over 2a. And in this case, I found out that my axis of symmetry is at x equals negative 2. Once I know that that's where my axis of symmetry is, I can use it to find my vertex. Okay, of course, the axis of symmetry always goes through the vertex. So I know that the vertex must have an x value of negative 2. And I use that to find the y value. I just plug in negative 2 into my quadratic equation. And when I do that, I find that the y value at negative 2 is negative 9. Okay, so the vertex then is negative 2 comma negative 9. And I put that over here into my table of values. And then I chose some other x values that were close to that negative 2 so that I could have a plot over here on my coordinate grid. So I'm going to go ahead and plot these points that I've put in my table of values here. If you need to pause this so that you can get this information down, that's great. If you're already with me, then you can go ahead and plot along with me. My first point is negative 5, 0. So I'm going to go over 5, up 0. My second point is negative 4, negative 5. So I'm going to go to the left 4 and then down 5. My third point is negative 3, negative 8. My next point is that vertex, negative 2, negative 9. And then negative 1, negative 8. 0, negative 5. And then finally, 1, comma 0. Alright, so I'm just going to connect my knots to complete my parabola here. Did I just say knots? I think I said connect my knots. What I meant to say was connect my dots. Here's my parabola. And as you can see, this parabola crosses the x-axis at 2 points. There's a point right here and a point right here. Those are both of my quadratic roots. In this case, my quadratic equation has 2 solutions. If I were to write those solutions, I would write it like this. My x values at -5 and 1 have a y value of 0. Okay, so that's how you would write the solution to this parabola. X equals -5, 1, and kind of just in brackets like that. All right, so there's example number 1. Let's go over example number 2. Same thing with example number 2. I went ahead and did some of the work ahead of time because I know that you guys can do this by now. I found my axis of symmetry first. And for the second example, the equation is x squared minus 2x plus 1. And I went ahead and used my formula for axis of symmetry, plugged in those values, and I got an axis of symmetry of x equals 1. So now that I know the x value at the vertex, I need to plug that in to find the y value at the vertex. So I just plugged in 1 for all the x's, solved that equation down, and I got y equals 0. So my vertex then is 1, 0. I went ahead and put that in my table of values. My x is 1, my y is 0. And then I chose some other x values that were right around 1 so that I could get a good picture of what this quadratic equation is going to look like when I graph it. So I filled in my table of values, and you should do the same thing in your notes. I'm going to go ahead and plot these table of values now. All right, once I plot my table of values, I get a parabola that looks something like this. You can see that my parabola just barely hits my x-axis 1 time. So this one has 1 solution because there's only 1 point where my parabola intersects my x-axis, just that 1 point. So if I were to write the solution to this one, I would write x equals, and then that bracket 1. Okay, and that means that when x equals 1, then my y value is 0. That's where my parabola crosses the x-axis. All right, so there's example number 2. Let's take a look at example number 3 in your notes.